So with this next video, we are going to be taught the important lesson of trying to do whatever is easiest first. Whenever you're confronted with a factoring situation, you should always ask yourself, is there a common factor that I can factor out? So, a trinomial that can be written as a product of two binomial factors may also have a common factor. Fair enough. Example 2, A. We're going to factor this trinomial. So when I look at this trinomial, if I notice that the leading coefficient is 2, that is, the number in front of the x squared is no longer 1. So what I've just previously learned is no longer useful in this situation. However, upon closer inspection, I may notice that all my coefficients and my constants are a factor of 2. So I can factor out the greatest common factor. And if I do that, I'm left with this very beautiful expression. And now, remember, so I can reduce the above or factor it so that it is 2 times x squared minus 3x plus 2. And what I'm going to do is I'm going to ask myself, only in the brackets, well, how can I factor this? Well, since the coefficient in front of the x squared inside my brackets is 1, I could use the sum product rule. So what two numbers multiply to positive 2 but sum to negative 3? Well, those two numbers are going to be negative 2 and negative 1. And in fact, if you want, you can multiply these three quantities and you should end up with the original expression. Let me go with B. Now, B is very pleasing to the eye. Why, do you ask? Because I can simply take a look, and it's more obvious here, for me anyways, that each term has a common factor of 5. So the greatest common factor that exists between all three of those terms is going to be 5. If I factor out 5, I'm left with 5 times y squared minus y minus 2. Always make sure to multiply through just to make sure I have the above quantity. So again, I could take a look at what's inside the brackets. What two quantities multiply together to give me negative 2 but add to negative 1? So I'm going to open this up with y and y. So what two numbers multiply to negative 2 but add to negative 1? Those two numbers must be negative 2 and plus 1. So there we have it. There's my solution. Now when we write down factoring, the order doesn't matter. But we like to have the constant factor in front, but you could have also placed this as y minus 2 times y plus 1. The statement of the order of your factors really doesn't matter at all. Last but not least, gross, C. So I just maybe have to think a little bit about C. And C, I notice that my coefficients all have a common factor of 4, for sure 4. Right? Negative 4 has a factor of 4, negative 16 has a factor of 4, and 128 has a factor of 4. How do I know 128 has a factor of 4? Because the last two digits are divisible by 4. That's how I know. But I'm just going to maybe think ahead. Wouldn't it be nice if I factored it out so that my leading coefficient in front of k is positive 1? Well, I can do that. I can do that by factoring out negative 4. So allow me to do that. I'm going to factor out negative 4 from the above. If I factor out negative 4 from negative 4k squared minus 16k plus 128, I'm left with k squared plus 4k. Now, minus whatever this beast is. Now remember, factoring out is very similar to dividing. So negative 4k squared divided by negative 4, I'm left with k squared. Negative 16k divided by 4k, I'm left with positive 4k. But negative 128 divided by negative 4, so maybe I'm just going to take some time and just do this. This is 32. And I'm just going to multiply to make sure. So negative 4 times k squared is negative 4k squared. Negative 4 times 4k is negative 16k. Negative 4 times negative 32 is going to be 128. And that's it. I'm done. I'm done with factoring in these. So really, to me, if anything seems really difficult, a great first step is to ask yourself, is there a common factor that exists? Good luck. Oh, wait, whoa. Ease up, Morin. I haven't finished factoring this yet. I'm sorry. And now what I notice is that my coefficient in front of the k squared is 1. Perfect leads to the sum product rule. What two numbers multiply to negative 32 but add to positive 4? So this tells me one number has to be negative, one number has to be positive, right? Because the product's negative. But the sum is positive 4. If you guessed it, it's these two numbers here. Anyways, now I'm done. All right, I'll talk to you guys later.